We're good to go. So my name is Apoorva Dave. I run go-to-market. This is Paul. Paul runs solutions architecture for customers. And we're going to start the way every webinar should start, which is with a joke. Okay, Paul, since you're the only one I can talk to directly, what did one workload ask the other?
I don't know, Apoorva. What did one workload ask the other?
By the way, I'm very sad. This is the first and only time. This is the like we're going to do this, for the first time, if you will. But one workload asked the other, "Can you keep a secret?" Huh?
That's bad.
Yeah.
That's bad.
Thank you very much.
Move on.
Thank you. Okay. All right. Okay, so let's talk about, you're here in general because you wanted to learn about workload identity and access management. So let's talk about this access component. Access today, it could be better, right? This is the reality of what organizations are seeing in their environment. When one workload needs to talk to another, a workload could be an application, it could be custom code, some prepackaged app you buy and run, it could be serverless functions, scripts, whatever, right? They need to access a number of other services that they need to get their work done, whether it's to access logic or access data. And all of those aren't in your control, right? They're not all in the same AWS cluster. They could be spread across multiple clouds, SaaS environments, so on and so forth. So you tend to see, in order to make that happen, a lot of hard-coded secrets, key sprawl spread throughout this infrastructure. Oftentimes, we hate to say it, reused credentials. And that's on the side of workloads trying to create access. There's a kind of sprawl on the other side of that connection too, which is service account sprawl. In many cases, we see a massive amount of service account sprawl because this environment is not tightly managed. Because the environment is not tightly managed from this access perspective, devs will also have access to machine secrets. After all, if they're coding up a serverless function or an app, they might be required to get a secret from somewhere else and put it in these machines. They tend to be long-lived secrets as well that kind of live out there for a long time. The end result of this is the nature of applications today connecting to other apps, APIs, SaaS services, creates a growing attack surface for your credential and identity environment. And most people are dealing with it with what I would describe as a mix of half solutions. In some cases, your devs may use a vault. In some cases, they might use Cloud IAM. You may be trying to build open source spiffy infrastructure, or you may have to do it yourself with custom implementations. I bet you for most organizations, they're actually doing a mix of these things. And that in and of itself creates a huge problem as people try to create a unified and consistent way of dealing with this infrastructure issue and access and management issue. Okay, so this is the problem we want to solve naturally. That's why I'm talking about it. And Ambit's approach is that we think you should manage access between workloads, not have to manage these low-level secrets and credentials. And what does that mean for us? We're building a centralized identity-based view of workload-to-workload access. So what that means is we want to use identities that connect to workload access policies across all these environments I described, right? Not just your new shiny cloud and Kubernetes environments, but literally everything you have to deal with. We also want to offload the development of authn from your developers, right? They have to code this into their apps today. Sometimes that's harder than others. In all cases, it's work that's not furthering your business. Along the way, we think we can help you move to short-lived credentials and eliminate the need for devs to have access to any kinds of these credentials as well, and deliver you something that can give you visibility into all of this access. And by doing this, we think we can build the identity control plane for workloads. And that gives you the ability to manage, enforce, and audit access from one workload to another across your distributed and heterogeneous environment. Okay, so that's the pain, and that's kind of what we're doing, right? If you want the, I don't know how long that was, 3 minutes? That's the 3-minute pitch on kind of what we're doing. Now I want to talk a little bit about the how we do it before we shift over to Paul to do a demo and show you how it actually works and how our console operates. So I'll spend a couple minutes here. And again, by the way, when we do just like one-on-one conversations, this is a place where I think we have a lot of questions from folks. So feel free to, again, pop in any questions you have into the Q&A area. That's under the three shapes in the lower right-hand corner. So the Ambit architecture looks a whole lot like an architecture for a different problem that you've probably worked to solve already, which is user identity and access management. And so for user identity and access management, imagine an Okta or a Ping or something like that. You've got users on the left-hand side of the picture and apps they're trying to talk to on the right, with some identity control plane above or out of band, which controls access rights. And we're going to do a similar thing, but workloads on the left and services or other workloads on the right. The way we approach this problem is through a process we call two-sided federation. And what that means is we develop trust relationships with your workload operating environments on the right and your services, your workload and operating systems on the left and your services on the right. That allow us to broker access between workloads. The way we do that is through a technical process and innovation we call attestation. And so as a workload requests access to a service, we actually use metadata from the environment the workload is in to cryptographically attest to the identity of that workload. So we're no longer depending on the workload showing up and saying, yeah, I'm who I say I am. I've got an access credential. I'm good, right? We actually don't know. If you have an access credential, does that mean you should have access? We don't actually know that. By shifting it to attestation, we identify the application and then use policies that you build into Ambit Cloud to confirm that that workload has access. Once you've confirmed that, we use our trust relationship with the service itself to issue an access credential on behalf of that service. Now, what's really interesting here is we can issue the shortest lived credential that that service understands, thereby enabling you to move to shorter lived credentials, even if the workload didn't expect that in the first place. Finally, we log all of this in an identity-based manner. So now you've got logs and visibility based on identity instead of access between IP addresses alone, right? All of this happens with Ambit Cloud being out of the data path. So all data between your workload and your services flows between those two. We don't see that data. We only see access requests. That's really powerful. One last component here, which I didn't mention. You'll see in this picture, we've got Ambit Edge. And Ambit Edge is, broadly speaking, it's a concept. And it's deployed or implemented either as a sidecar in your Kubernetes clusters for your applications. It can be implemented as an agent for VMs. Or we have code which operates as an SDK that could be integrated directly into your workload. All of that is what enables you to have your workloads talk to Ambit Cloud. Now, in the case of the sidecar or agent, we describe this as a no-code auth methodology. The agent in Ambit Edge acts as a transparent proxy, which means your applications don't need to be configured to know about Ambit, and you don't have to change the way they behave in any way, shape, or form in order to have them work with Ambit. We take care of all of that. All they do is normally request data the way they would in any other scenario. Obviously, if you choose to go the SDK method, then you do need to code access from your workload into Ambit Cloud, but we give you the option depending on what works best for you. For example, we have a customer who's deploying Ambit with serverless workloads, and in that case, the SDK works better for them. We have another customer who's using custom prepackaged applications, and they don't have any way to change anything going on inside that app. the Ambit Edge sidecar works great for them because it works transparently and the app doesn't even need to know it exists. All right. Let me drive forward one more. Let me give you an example here, and then we'll shift over to a demo. This is a customer of ours who was accessing a very sensitive data through a set of workloads going to Snowflake. And these workloads were split. Some of these were custom applications, and others were prepackaged applications. So this was the customer I was referring to in the previous slide, who also had prepackaged applications. Now, for most of these workloads, they were configured to access Snowflake via long-lived secrets. And a couple things. One, that meant that the workloads themselves would oftentimes have either admin credentials or a long-lived API key embedded into the application. They could access Snowflake, but there was no verification of application identity. So there was no attestation to say the app is who it says it is. And any work to rotate secrets would be entirely manual. You need to rotate them on the Snowflake side, and then you'd need to either go rotate them on the workload side, or even worse, ask your developers to rotate them on the workload side. All of this led to an untenable system in the sense that, as more and more sensitive data was going into Snowflake, they wanted to ensure that only the workloads that they had defined were accessing that data and even accessing it at the right time. And they had no way to do that. So enter Ambit. That picture on the right probably looks pretty familiar to you. And we were able to entirely automate the secrets lifecycle. We removed admin access to the credentials because we were able to inject real-time credentials on behalf of the workloads when they were requested. What's interesting here too is because because Snowflake supported short-lived credentials, we could inject short-lived credentials into these workload access requests, even for those prepackaged workloads that were only configured to use long-lived secrets. They didn't need to know that we were injecting short-lived requests, but we dramatically improved the security of accessing Snowflake on behalf of those workloads. Final thing, which is pretty interesting too, we're able to support conditional access policies. So it's not only that you have the right, you are the right person or right workload, and you have policy-based access, but we could apply different conditions. For example, are you being actively managed by CrowdStrike or Wiz? Is this a time frame that you're allowed to access data in? All of these kinds of conditional policies dramatically improve both your security and your ability to drive compliance. We've talked through a number of different use cases here, but I'd say the high level is that people use us to protect access between workloads to their most sensitive data and infrastructure, whether those are data warehouses and data lakes, SaaS services that aren't fundamentally under your control, or critical infrastructure that reaches out and touches other components of your critical infrastructure. We can apply identity access management and a zero trust model for your workload access. I'm going to skip this for now, given time. And let's start getting ready for a demo here. There's a couple things I want you to see in this demo. First of all, we're going to show you in our console how you do policy creation and how you can drive access based on identity instead of secrets. We'll show you how credentialing works through these trust relationships, trust providers and credential providers. And finally, we'll give you a glimpse at conditional access, where you can gate access based on additional conditions. And I think in this case, we'll talk about your security posture using one of our partners. Paul, are you warmed up? Are you ready?
I am.
Okay, great. I'm going to stop sharing. As we switch over to Paul, this is a great time for additional questions. So if you have any questions, feel free to drop them in the Q&A window, and we'll pick them up either during the demo or right after. Over to you, Paul.
Great, thank you. Thank you, Apurva. I'm just going to start off with the heart of our platform, which is the access policies. The access policies are really what determines what client workloads are able to access what server workloads. And so this is a policy engine where you can determine what has access to what. And looking at one of these lines, you can see the 5 components of our policy. The first is the client workload. You can think of this like a username in user environments. This is there so that we can identify that workload, and it's not meant to be secret. The next is the trust provider. This is where we get that attestation that Apurva was talking about. This is us federating with the environment that the workload runs in so that we can get a cryptographically strong identity for that workload and know it is who we think it is. On the right side here, we have the server workload, which is just the service that that client workload is trying to access, and then the credential provider, which is how we access that, that workload. What credential do we use to actually access the workload? Here in the middle, you might see this little icon. It looks like a traffic light. That is a conditional access policy. And so this is showing that this policy is not just does that client workload have access to that server workload, but then also does it have access and is it secured in an appropriate method? So now I'm just going to dig into each of these a little bit. I'll start with the client workload. So this is how we identify those workloads. It can be things like a host name for a VM, if it's a VM-based client, or a host name with a process name so that only that single workload on the host is able to access the resources. Say, if it's not coming from that specific process, we won't even evaluate it. Likewise, if we're looking at things like, say, a Kubernetes deployment, we can look at the pod prefix name, and that'll identify all the various pods within that deployment as one group of applications, so you can give them the same rights across each of those pods. And of course, as it scales, those new pods, as they come online, will get those same rights. There's a variety of other things that we can do, things like the Ambit client ID, which is our edge component. And so then we could say, hey, anything within this Kubernetes cluster we're identifying as one group, or a source IP address. There's a variety of things that we can use in that. Next, looking at the trust providers, this is where we get to that cryptographic identity. So, of course, with the cloud service providers like Azure and AWS, we can use their metadata service and instance identity documents or tokens signed by them to identify that client workload, whether it's a Kubernetes workload or clientless workload or serverless workload or a VM running within those environments. We can also do the same thing with Kubernetes environments. One example is, if I wanted to, I could take the key pair from the Kubernetes environment and federate with that Kubernetes cluster by just uploading the public key into Ambit. That way we can validate the identity documents, or those service account tokens, generated by the cluster, and we can validate that they actually were created by the cluster. Alternatively, if you're using something like an OIDC server, we can just connect to that OIDC server and pull back that public key automatically. Now that we know the client workload and have cryptographically validated its identity, we now look at where it's connecting to. So that's looking at the server workload. And the server workloads are actually pretty straightforward. If I look at, say, Snowflake, it's really just, what is the host it's connecting to? What protocol is it using? In this case, because it's the Snowflake SDK, I'm using Snowflake's proprietary protocol. And then, what ports is it using to connect? And this, it's coming into Ambit's proxy on 443. We are decrypting that traffic, injecting the credential, re-encrypting it, and then sending it out. And then, of course, how are we authenticating? We're using a Snowflake job. So this is always paired with the credential providers, which is how do we create the credential that that service can use. And if I look here, my Snowflake job, that I'm just defining the things within Snowflake that will be used for authentication. So the first is, of course, my account ID, and then the second, the username that I'm connecting with. The Ambit system creates an RSA key pair, and we show the user the actual Snowflake command that they would need to allow us to authenticate using JOTs signed by the private key. One thing that you should note here is the admin never sees that private key. It only has access to the public key. So there's no way that that admin could ever compromise the private key. That's one key thing that we're doing here, making sure that those credentials stay secret even from the admins. And then finally, we have those access conditions. And this is where, through our integrations, we've connected to CrowdStrike and Wiz, and then created access conditions based on that. So if, say, I was looking at Wiz for my Kubernetes cluster, I, of course, have my endpoint, but then I'm looking at things like, hey, is it currently connected? Is that cluster connected? When's the last time I saw it? Making sure that it's currently being protected by Wiz. And so all that comes together into the access policy where it can be evaluated whenever a client workload wants to access the server, where we identify the client workload, identify what it's connecting to, if that workload is still secure, and then automatically provide access. Now, the final component to close the loop on this is, of course, reporting on all of that. So we log every time a client workload tries to access a service. And we report it to you in human readable form, so I can actually look at what that client workload is, production application, the service it's trying to access, in this case it's Redis, and then I can actually look at the details around that. So I can look actually into all the information about what was happening within that. If I looked here, I could see, a request to Redis, a response coming back. If I look within that request, I can see exactly the IP address that it came from, information about the application pool, the event, and then what we did to that connection, as well as some metadata about it. One thing you should note here is we do not collect the data within the stream. We only collect metadata. So your private corporate information stays within your environment, and we never get to see it. Of course, along with those workload logs, we also have audit logs that show everything that the admins are doing within the system. And of course, all of this doesn't just stay in our system. We can send it off so you can analyze it within your SIM. One just quick thing that I also want to mention is our edge components. So we want to make it very easy for you to deploy, whether it's a client on a VM or within your Kubernetes cluster, where we have our own Helm chart, and you can easily deploy it and then annotate your pods so that you can add our proxy directly in them. So it's really a very quick deployment that you can add to your existing process. Apoorva, I'll now hand it back to you.
Nice job, Paul, as always. Paul's a pleasure to work with. Okay, so I'll bring the slide back up here. And I know we're at time. So if you have to run and you do have questions, you should feel free to reach out to us. You can reach out to me directly, Apoorva, APURVA, @ambit.io. If you do have a few moments, we're happy to take your questions. I also just wanted to flash up here on how you get started. So our product is self-service. It's really designed to be self-service, and we have a free tier that matches that. So up to 10 production scale workloads can run on our free tier, and we're happy to actually help you get that up and going as well. And then we scale pretty efficiently, right? So we want to make it easy for you to get this rolling, and you can get started on your own, or we're happy to help you. And as kind of a way to get rolling here. We know this is new technology, and we want to make it as simple and easy for you as possible. Paul, are you ready for some questions?
I am.
Okay, so the first question is, the question from the audience is, do you have to do a custom integration for every service that I'd like to work with, or do you have some kind of generic integration that'll work for me?
Yeah, so absolutely. Really, when thinking about integrations, you should be thinking about the type of authentication. And so there's a few standards-based authentications that we support that are used widely across the services that you'd be using. And so we don't need to do custom integrations for each individual service. It's these broad things such as OAuth that we support.
Right. And I'll just reinforce, if you're ever having issues getting something set up, we're really happy to help you, do that. Or if there's like an advanced authentication method you'd like to support, that's something we could work with you on. But generally, we're designed to broadly scale to all of those integrations you're going to need. Next question is, the question is, I can see how this works across the clouds and Kubernetes. What about on-premise environments, and how do you do attestation? I'll take that one. So generally, what we do is we leverage metadata from the environment in order to do attestation. So in on-premise environments, there are usually various forms of metadata we can derive to do attestation. Those may consist of your VMware or virtual machine platform. They might consist, if you're using Kubernetes on-prem, it will work similarly. And there are extended methods we can use as well, which we're happy to get into detail with you about. Definitely designed to work on-premise as well as in the cloud, and that's very important. Next question is, a little bit around how does this relate to Spiffy? Paul, would you like to take this question, or would you like me to take this question?
Why don't you take it?
Sure, I'd be happy to. We've been talking a lot about Spiffy. It's pretty cool. It's kind of like a cool open source project around identities. There's a couple things here. So first of all, Spiffy is really awesome. If you're using Spiffy today at scale, first of all, kudos to you. That's still a significant amount of engineering work, but it's another form of identity. And we can absolutely use this identity to manage access to whatever other services you need. That's really valuable. That consistent source of identity is fantastic. One thing to note, however, is that Spiffy does result in a stored secret, right? It ends up in a stored identity secret. That does have a form of risk. We try to avoid that by using attestation against native forms of identity, like service account tokens and other forms of metadata that inherently exist surrounding your application, not embedded in your application. The other component to think about is how broadly do you need to connect your environment? For example, if you're operating solely within a cluster, Spiffy could be a great solution for you. But if you're connecting to other clusters, other clouds, if you're connecting to SaaS services or partners APIs, think about your business partners and services that they may run. In those far-flung infrastructure resources, you don't have control of how to implement identity. And you'd probably be pretty lucky if those partners had implemented a Spiffy infrastructure based on Spire or something similar that you could actually use and access and federate with. So in those cases, it's really hard to apply a consistent IAM model, whereas Ambit is designed to allow you to do that. We're at 5 minutes past, so I'm going to call it here. There's a couple more good questions coming in. My promise to you is that we'll get back to you individually on those questions. But in the meantime, I just wanted to thank you for joining us. And I hope you either sign up for our app or you just reach out to us, and we'd be happy to talk through your infrastructure, your environment, your questions, and get you started on your journey for Workload IAM. Thanks again for joining us. Thanks to my co-host, Paul, for doing an awesome job, and happy holidays. We'll see you again soon.